Hello, dear students. Welcome back to my YouTube channel. I guess I am audible and visible to all of you. Hasana beta. Hello, beta. Am I audible and visible to all of you? One second. One second. Today somehow network, right? It is not good. But still, I will just try to just finish the lecture as soon as possible. Okay, great. So let us start the lecture now, no? Okay. So in the previous class, we concluded uh, store in the inductor, and then which part we concluded? Okay, self-inductance, right? Or self-induction. So self-induction part we concluded in the yesterday class. Okay, and I hope that the topic is very clear to you. One topic that I didn't just show here, now that is our LR circuit growth and decay, and basically the topic is not now in your NCERT, and it is not important for your any examinations. Okay, so let us start the new topic known as mutual induction. Known as mutual induction. Mutual induction. What is mutual induction? If we are having a circuit like this, one coil, this coil is with your battery, this one, right? One more coil which is closer to this coil. In this coil, we don't have any potential source. We are having a galvanometer. Done. So this particular thing known as primary coil. This one is known as primary coil. This one is known as secondary coil. Secondary coil. What we observe that when we are just closing this key, when we are closing, okay, so when basically we are closing the key, what happens now? Current start flowing through this particular thing, right? And we know that the magnetic field will be in this direction. We know it. So this magnetic field will go across this one also, no? Okay, you can see here my current is going from 0 to some, let's suppose 6 ampere, suppose example, right? My current is going from 0 ampere to 6 ampere. You are saying that the current is varying. If my current is varying, that flux which is associated with this current, that will also vary, no? If this flux is varying, that means this flux is varying. So if this flux is varying, flux is second, it is varying, right? It is varying due to the current change in first one. Done, sir. Due to this flux change, what happens? Induced EMF is present, right? Due to this induced EMF, we are getting induced current. We are getting induced current in my secondary coil. Okay, one second. Look now, here this current is changing. If this current is changing, so we are having this flux. So this flux is also changing. If this flux is changing, the same flux is here, this flux is changing. Now the flux which is associated with the second coil, this is changing. We know that if flux is changing, we are having induced EMF. If we are having induced EMF will give induced current. So we are getting deflection in galvanometer. We are getting deflection in our galvanometer. Very easy, extremely easy. Okay, done. So you will write flux which is associated with the second coil, it directly proportional to the current in first coil. Okay, So what is meaning of it? The flux that we are getting in our secondary coil, it is just because of the current in the first coil. Okay, sir. So can I write now flux in secondary coil is equals to a constant M, that I1? Yes, sir. What is M? It is coefficient of mutual induction. Coefficient of mutual induction. Coefficient of mutual induction. Done? Or we can write in different way also. How, sir? Let us suppose my current change here in this particular thing. My current is not I, it is changing, that is delta I. 1. My flux is not delta phi 2, I will write it as a not phi 2, I will write it as a delta phi 2. Change, no? Suppose change delta phi 2. So I can write delta phi 2 is equals to M delta I1. This equation you will get it in your NCERT. Meaning is same. Meaning of this equation and this equation is same. Done? Don't get confused with these things. We can write one more thing. We know E equals to minus d phi by dt. Now, this equation we know very well. So can I write now induced EMF in the secondary coil, is it equals to minus change of flux in secondary coil? Then, sir, minus d by dt. What is phi 2? I guess phi 2 is nothing. It is M I1. M is constant, so can I write E2 equals to minus M di1 by dt. In our self-induction topic, it was E equals to minus L di by dt. It was minus M di by dt. Done? Any confusion, beta? Any confusion? I will give you 1 minute so that you can just wrap up whole things, and if you find any doubts in it, you can just ask me. Okay? Clear now? Easy, beta? Look, I am not explaining too much now, no? I guess the reason is on reason you know, no? That we discussed these things now on a very good note in a previous chapter, right? Look now, I will give one numerical, a very good numerical. Numerical is like my current is given to me. Current is I equals to, it is I naught sine omega t. Equation of my current, it is given to me. Mutual induction M is given to me. We have to find out E. What will be the value of E? So what is the value of E? So we know one equation, that is, sir, E equals to minus M di by dt. E means minus M is M. I can write d by dt. Instead of I will write I naught sine omega t. Right? So minus M, look, I naught is constant. I will take I naught outside. The differentiation of sine omega t will be cos omega t, and differentiation of omega is omega. So my answer came out to be E is equals to minus M omega I naught cos omega t. This one is my answer. This one is my answer, right? If somebody will ask you what will be the maximum value, max value. For max value, what is the value of cos theta? Any value? Yes, sir. So the maximum value, it depends on the angle, now cos omega t. If my cos omega t is maximum, what is the value of cos omega t maximum? Sir, it is 1 only. It is 1 only, no? So I can write the maximum EMF of the secondary coil equals to m omega I naught. Just note down these things. Note down these things. Okay? Note these things down. Easy, no? Easy or super easy? Look, after everything is not that after everything, I'm just giving you time now so that you can just have a view on the numerical, how you need to manipulate these numericals, right? Okay. One more numerical. I am taking now the classes, shorter classes, right? So let us suppose my m is given as 1.5 Henry. Then if the change in current is given to be 20 ampere. Done, madam. If my change is current is given to be 20 ampere. Time is given as 0.5 second. 0.5 second. Find out delta phi. When anything is given to you now, you need to manage the numerical in such a way that you have to find an equation that relates these given inputs. I guess we are having a numerical. Sir, phi is equals to, is it mi? Right. One more formula is delta phi equals to m delta I? Yes, sir. Delta phi we have to find out. M is equals to 1.5. Delta I is 20. So I can write 15 by 10 into 20. Cancel out. I guess my answer is how much? 30 Weber. My answer is 30 Weber. Easy? Easy or super easy? Easy or super easy? Huh? These are very simple numericals. No? The numerical that I now will show you, that is very crucial one, a good one and an important one. Now numerical. Numerical is 2, I can write 2 conducting loops of radii R1 and R2 are concentric and are placed in the same plane. If R1 is more than R2, the mutual inductance, that is M between them will be directly proportional to. And first option is R1 by R2. Second option is R2 by R1. Third option is R1 square by R2 square. Fourth option is it is R2 square by R1. How we can deal with this numerical? Look now. 2 conducting loops of radii R1 and R2 are concentric. That means single center. One loop. One more loop. This radii is R2 and this one is R1. Done. Mutual inductance is M is given to us. Let's suppose current I is flowing through it. Current is flowing through it. If now I is flowing through it, so we are having a magnetic field around it. Okay. This magnetic field is associated with this also. Yes, sir. We know now. If this is, let's suppose this is my coil. So what will be the magnetic field inside? It will be cross, right? Cross. Here it is dot. Same, so inside we are having magnetic field due to this current carrying loop. Okay, sir. Do you know what is the value of this B at the center? Do you know? Huh? Is it nu naught I divided by 2R? Yes, sir, it is. It is nu naught I divided by 2R. Done? Okay. Now, what is the formula for phi? Sir, I guess flux in second is equals to, it is BA cos theta. BA cos theta. Magnetic field is due to first one. Area is the second one. Done. What is B? Is it nu naught? Current is I1 flowing divided by 2R1. Area of second is pi R square. Pi R2 square. Cos theta, it is cos 0 degree. Cos 0 degree, that is 1. So can I write now, is it nu naught I1 pi R2 square divided by 2 times R1? Yes, sir. It is phi 2. Phi 2. One more thing that we know now, that phi 2 is equals to m times I. So instead of this phi 2, I will write here now. I will write m times I. M times I, but which I? I1 equals to nu naught I1 pi R2 square divided by 2 times R1. I cancel out. So you can see here, my m is equals to nu naught pi R2 square divided by 2R1. Nu naught constant, pi constant, 2 constant. So m is proportional to the R2 square divided by R1. Option number 4 is correct option. Option number 4 is correct one. Done. One more numerical. If we are having a straight line, my straight line, if we are having a straight line, done. And if in this straight line my current I is flowing, now perpendicular to it we are having a loop. This is my loop now, perpendicular to it. What will be the m value? I guess m means phi 2 equals to m times I1. Yes, sir. So you can see here, what is phi? Is it BA cos theta? Okay. You can see here now, look, this pen represents wire, this hand represents coil. Okay. Now, if current is going upwards, so magnetic field is inwards. So here, magnetic field B, that is inwards. So area would be upwards, now area vector. So what is the angle between them? Sir, 90 degree. So what is cos 90? Sir, cos 90 is 0. So flux is 0. If flux is 0, that is mi1, so m is 0. So m is 0. Okay, m is 0. So you need to think about it, no? You need to think about it, how m is 0. So I have given you the proof that states that how m is 0. Very simple one, very easy one also. Done? Look now, beta. If I am not taking the long classes. I know that you are very busy in your daytime, right? So I am not taking your long classes, but I am giving the 100% content, right? So look here, we are having a loop, primary loop. So here we are having a secondary loop. Current I1 is flowing through this one. Done. Length is L. Number of terminals is N1, number of terminals is N2. Okay. Done, beta. Area is A. What is magnetic field? Is it nu naught Ni? Yes, sir. Magnetic field of first one, is it nu naught N? What is N? N means N1 per unit length I. It is here I1. What is phi 2? That means this phi 2. It is primary. This one is secondary. What is phi 2? Phi 2 is simply equals to, is it m times I1? So I can write m. What is I1? No, we don't know I1, no? I1. So one more thing, so phi is equals to m times I1. So I can write m equals to phi 2 by I1. I can write like this, no? Done? Or there are a lot of ways to manipulate it. Let us suppose we are having phi equals to nu naught n1 I1. Done, beta? But what is phi basically? Phi is equals to, is it nu naught ni? No, it is b. No, it is b. Sorry, it is b. Phi is ba cos theta. Phi is ba cos theta. Is it ba cos theta? Ba cos theta. Done. So we are having number of terms. I can write phi 2 equals to n2, b1, area 2, and cos 0 degree. n2 is n2. What is b1? b1 is nu naught n1 by li1. What is a2? Area of the secondary coil. I can write a is at a na, and cos 0 is 1. I can write here nu naught n1 n2 I1 divided by L times A. Divided by L times A. Listen to it now. So if we are having a solenoid, so L is equals to, it is nu naught n square by L times A. We can write like this now. So what is L1 now? L1 is nu naught n1 square by L times A, and L2 is nu naught n2 square by L into A. Now multiply n1 and L2. Multiply these things now. I will multiply L1 into L2. It came out to be nu naught square n1 square n2 square A square divided by L square. Can I write now? It is L1, L2 came out to be nu naught N1, N2, A divided by L whole square. I can write it as a nu naught N1, N2, A divided by L equals to under root of L1, L2. Do you know what is this one now? It is M. So mutual inductance is equals to root of L1 and L2, and this identity is an important one. This one. You need to remember this identity. Take your time. I am giving you 1 minute. Just take your time and just let me know if it is easy or tough. Easy or super easy? Easy or super easy? Okay. So look, the only formula that you need to remember for these derivation, that is only m is equals to under root of L1, L2. L1, L2. Now, I'm just giving you the one more concept, and that concept is, look, if we are having one coil like this, one more coil, you can see here now it is 100%. It is 100% coupling. Okay, magnetic field lines are 100% intermixing. 100%. You will write it as a perfect coupling. It is perfect coupling. For perfect coupling, that k is equals to 1. K equals to 1. So basically the equation is m. So the but it is ideal case. It is ideal case. Originally m equals to k under root of L1, L2. Okay. So if it is 100% coupling, you have to take k equals to 1. If it is not, let's suppose we are having this one. Now look, this one. This one now. So here just k is less than 1. One more case. If we are having something like this, look. Like, so look here. This is my magnetic field. This is my area. Just increase it now. So angle is 90. cos 90 is 0. Cos 90 is 0, so m equals to 0. So k equals to 0. So you are having three values. K is 1, 100% perfect coupling. K less than 1 when there is a gap between them. And K is 0 when there is no flux change. When there is no flux change, you can write K equals to 0. Done, beta? Easy, no? Easy or super easy? Easy or super easy? Look, these things are not very important. Still, I'm just trying to just give you some kind of knowledge, no? At the end, you won't just tell, no, sir doesn't just teach us these concepts, right? Done? Okay, now we are having combination of inductors, combination. So combination is similar to other resistor. If we are having two resistors like this, R1, R2, what is R equivalent? R1 plus R2. In the same way, if we are having one inductor, one more inductor. Okay, so you will write M, no effect. There is no mutual inductance. Why? The gap is more. L1, L2. So what do you write? L series equals to L1 plus L2. But thing is, if gap is more. One more, if we are having parallel, sorry, it is not like this. Why I'm not understanding why I'm just going too fast. L1, L2. So you will write 1 by L parallel equals to 1 divided by L1 plus 1 divided by L2. So these formulas, you need to remember these formulas. Done, beta? Done? Okay. So look, I am not giving you something that is not coming to the examinations. I am giving you those things which definitely will come into the examinations. Look, I'm not teaching you some burden things, right? That LR circuit growth and the GK one. You won't find anything in your examination from previous 5 to 10 years. You won't find anything, right? You won't find any topic in your NCERT also. But yes, these topics you will find it. There is one more formula that L is L1 plus L2 plus 2M. That is not asked in examination. Okay, so don't just take maximum things, right? Take only those things which are important for your particular examinations. So for our examinations, we don't have any specific thing. Now we are having only that thing that I'm just teaching you here, right? It is more than enough. Okay. So in next class, we will be starting lecture number 6. Okay, it is lecture number 6. And in this particular way, we will complete our lecture in coming 2 to 3 days. In coming 2 to 3 days, we will complete whole chapter. Okay. So I need now your response. Is this chapter easy or super easy? Is this chapter or is this topic easy or super easy? Huh? Easy or super easy? I want your response. No? I need your response. Is this easy or super easy? Madam? Super easy? So do one thing now. Just complete your topics, complete your backlogs till this Saturday, and then from Monday we will just try the classes for more than 1 hour, right? So I want you to be just chill in your life, no? Don't take maximum things on your shoulders. Done? And if you have any confusion or if you have any problem, I was ending the class earlier. Basically, in these particular days, I'm getting some sort of migraine. My health issue is I'm having the health issue. Okay, so I can't take the maximum things, just because of the lightning things, right? So once I will get my new equipments, then we will just start the classes. So most probably from Monday we will start the classes, but don't worry about anything. No, don't worry about anything. And I'm not compromising any content for you now. Don't think about it. The sir is not taking anything seriously now. Okay. Don't think about any these kinds of things, right? So you can just check your NCERT. You can just check your any module, any DPPs. You will find these topics in your books, right? And don't worry about anything before starting off your examination. We combinedly now we complete these things, right? Couple of times. That means after this particular session, we will be having NCERT session. After NCERT session, we'll be having top numerical sessions. Top numerical session, then we will have PYQ sessions. So look, one is this revision that we are just going. Then we are having NCERT revision. We are having the top numerical revision. Then we will have PYQ revision. So before your 12th examination, we will be completing most probably 4 times the whole 12th syllabus. 4 times. Okay. And with this thing also, we will be completing 11th also, right? That will just give you a boost to your 11th preparation without having much burden on your shoulders. Done, beta? So I guess for today, we just completed everything. Huh? So let's see tomorrow then, okay? Bye, beta. Bye.